Hey, Dr. Andrew Little here with the Awesome Lab. Looking forward to a really cool project this year on acoustic recording units. So this is an acoustic recording unit. And basically what we do is we collect data out here on avian species. So bird species is basically a listening device we have out in the field. That device is recording depending on the settings that we put into it throughout the day. So it could be in the morning, afternoon, whatever. And essentially it stores all this data on an SD card. After it takes that data, after we have that data in an SD card, we have to take and analyze that data. And that's basically where we want to work with you guys on developing an efficient workflow for storing the data, organizing that data, and then analyzing that through a program called BirdNet. And that will allow this to be a very easy tool so that we can have people in the field, biologists, students, researchers, out collecting data at mass and have a very, very easy GUI interface workflow that allows them to upload this data and analyze it and validate those clips. So what we do is once we have this unit out here in the field, we take and we pop this off. Inside it has batteries in here and it has this SD card. And so once we get the data, we come out to the field, we pop that SD card out, and now we take and replace it with a different empty SD card, and now we have all of our data stored on this for acoustic recordings. We're going to go into the lab in a moment and actually look at how we upload that data and begin the analysis process.
Hi, I'm Dr. Grace Schuster, and I am a previous member of the Awesome Lab. Once we bring in the SD card, it's going to have about 1,000 different 1-hour audio clips on it, and we have to be able to analyze, review, and all of that noise from the field. So we bring it in and we use a automatic classifier that uses AI called BirdNet, and it goes through and it will analyze and pull out all of those individual clips and which birds are vocalizing. Then it will give us all these. It will break them down into CSV files. And you see here we have about 1,000 different CSV files that need to be analyzed. And what we want is a interface that is able to sort through these and allow different biologists, researchers, just like Andy said, to go through them and pick out which clips they want to be able to use. So after we bring in that SD card from the field, it's going to have multiple different WAV files on it that all amount to about an hour. Here at the BirdNet Analyzer, we're going to use it to bring in those input files from an input directory. Then we are going to select an output directory, which is just a file on a computer, and it's going to submit the different CSV files once the BirdNet goes through and analyzes those 1-hour recordings. We have a bunch of different settings that we can change with BirdNet. The first and most important one perhaps is this minimum confidence threshold. That's going to ignore the BirdNet clips that are below that threshold, that have a confidence level below 0.25. So what we want to do is change that to 0.1. So it's going to ignore all those different BirdNet clips that are below a 0.1 threshold. The sensitivity we are going to ignore, and the overlap we are going to ignore. The species list, we're going to custom our species list by location, and we're going to put in a different latitude and longitude. And we're not going to mess with the time of year. We're just going to do start it year round. So it's going to pick up birds from year round that might be in this location. We're going to use the BirdNet model version 2.4, the newest version that we have. And it's going to give us a CSV file that's going to go into that output directory. Some additional columns that we want to include for our CSV is our latitude and longitude, the week, the minimum confidence as well. And once we have that, we're going to go ahead and analyze. And we already actually have our BirdNet running right now. And as you can see, we've been probably having this run for about 30 minutes, and it has only gotten to 12 of our 600 different files. So as you can see, BirdNet does take a very, very long time to run, and it's a lot of data. So what we want to do is have a interface that can help biologists and researchers be able to calculate this data or analyze this data with the BirdNet Analyzer much quicker. And we also want to provide them with opportunities to validate their BirdNet outputs so that we can make sure that BirdNet, which is not a perfect technology, we can make sure that it is doing the best that it possibly can, giving us the best results. So here we have a simple workflow of kind of how we want this procedure to run. So again, first we collect the audio data from the recorders. The user of the ARU can then upload those raw audio data to a platform called Globus Connect, or the platform that we use, either one. And that also stores the raw data for them in the Holland Computing Center attic. On our platform, we also want the audio data to be able to run through BirdNet, preferably on a high-end computer within HCC, such as the Swan. But we want BirdNet to be connected to this platform so that it can be easily accessed. And the reason that we want it to be easily accessed is so that we can incorporate our validation procedures into the BirdNet outputs as well. So they can do it in all one big sweep. So from when the audio data is run through BirdNet, the user of this platform can then select their focal species of interest. So like American goldfinch or American robin or some species like that. Then on this platform, they can choose to listen to a different number of clips to validate the detections for these different species and calculate performance metrics that we have used in our past research. Again, this is just so that they can make sure that what BirdNet is identifying is actually the species that is present there. Then once the validation is completed through that platform, they can download those detections, those validated detections from that platform, and they can also use it to improve BirdNet performance someday when we work with other people.
Hey, this is Dr. Andrew Little back here at the Awesome Lab. So again, we're excited about this process and for your involvement, and we're hoping this is an opportunity for you guys to work through a kind of a complex approach, but ultimately something that will allow our biologists, researchers across not only Nebraska, but really the nation and hopefully the world at some point, be able to pull this type of data, this acoustic data, in to a platform, kind of creating this step 1, 2, 3 simple process. Individuals that may not have that experience with the coding side of things, we want to have a GUI interface. And this will allow us to be able to collect this data in mass, store the data, and then analyze it, as Dr. Schuster mentioned, through BirdNet, and then output that data where we can have maybe some graphical interface as well that can show us some of the outputs and make it really easy and user-friendly. And again, the value of this type of project is that ARUs are really popular right now. They're growing in popularity because we can collect literally thousands and thousands of hours of data, terabytes of data. It's really easy to do that. The problem is on the back end, and that's the analysis and the storage and management of this mass amount of data. And that's what we're asking for your help to be able to develop in phase 1. Some of these processes that were noted here today, and then also knowing that this is actually phase 1 of a multi-phase project where we want to incorporate other types of data like weather data, satellite imagery data, etc. And this will not only allow agencies like Nebraska Game and Parks Commission or Pheasants Forever to collect a lot of this type of acoustic data, but it will also allow us to be able to track trends through time. So again, join us in this project. We're hoping we can build a really awesome and collaborative team to be able to solve this complex problem.